Okay, so we're going to look at, just some of the kind of general things about the kinematics unit on the final exam. All right. Obviously, the first thing we went over in the kinematics part of the unit was a review of Science 10, and that was about scalars and vectors. Okay. Absolutely fundamental understanding there for the rest of the course, knowing what things are scalar, what things are vector, okay, how that affects how we calculate things or how we measure things. Okay, so certainly we need to have that understanding. Okay, we looked at that from a standpoint of v equals d over t, which was also a review of Science 10. Okay, if I write v equals d over t this way, I mean that speed equals distance divided by time. Okay, speed and distance are both scalar quantities. Direction doesn't matter. Okay, but if I write it this way, now suddenly it's velocity equals the change in position or displacement divided by time. So that's final position, okay, minus initial position divided by time. It's calculated differently. Okay? As a result, it has a much different value, okay, when we look at it in a problem or on a graph. Okay, so those are things we need to keep in mind because you could be tested on your ability to like interpret a graph to do with this. Okay, if I give you a position versus time graph, right, that looks like this, kind of goes up and down and whatever, okay, I might ask you scalar vector questions about that graph, like what's the total distance traveled? Okay, well, the total distance traveled is however far here, plus however far here, plus however far here. But if I ask you what's the total displacement, the answer is 0, right? We calculate those things differently and we need to have an understanding of how that works. That's something that's, like I say, fundamental to what we've done in this course. Okay, is there going to be a 5-mark question in the written response about v equals d over t? No. Okay, there's not. This is the Physics 20 final exam. I wouldn't even put that on a Science 10 final, right? But it's still something that's fundamental to our understanding of how these things work. Okay, so other things would be really look for in the questions, okay, what am I being asked to solve for? Some of us got burned on this on the kinematics exam when a question asked, what's the final velocity of this object? And we didn't put what on it? Yeah, we didn't put a direction on it. Okay, so we didn't give a velocity, we gave a speed instead. Okay, we have to remember little things like that. Read a question, is it asking for a vector quantity? Is it asking for a scalar quantity? Okay, which one? Okay, make sure we solve for the right thing and include all the information that we need. All right, now v equals d over t, like we said, there's not going to be like a dedicated v equals d over t question, but was it an important part of some other things we did? Right, could be part of a boat question. Right, when you're being asked how far downstream does something end up, right, you have to use v equals d over t for that. It's part of projectile motion, okay, calculating the horizontal distance traveled by a projectile. We use v equals d over t for that, okay, things like that. So it's involved in some other things. We need to know when the other times are that it might apply. All right, from scalars and vectors, we moved into graphing, which was also a bit of a review from Science 10 because we went over the same graphs. We went over position versus time and velocity versus time graphs. I would expect to see them on the final exam. Okay, maybe it's just in the multiple choice. There's a few graphs in the multiple choice. Okay, there's going to be some graphing in the written response as well. Okay, being able to calculate certain things from the various types of graphs, or use y equals mx plus b on a linear graph. Okay, all things that we've done in this course multiple times, but we certainly do need to review. Okay, what's on a position time graph? What can I calculate? What's on a velocity versus time graph? What can I calculate? Okay, and getting those skills, not necessarily memorizing it, but remembering how to determine, okay, on this kind of graph, the slope will represent this because I'm dividing these things. Whereas on this graph, the slope represents something different because I'm dividing different things. Okay, that's the kind of skill set we'll have to have for the graphing. And like I said, both sections of the test will include some graphing components to it. Okay, then from there, we went on to acceleration. Right, and there'll definitely be, some problem solving to do with acceleration. Maybe not of its own accord, but it was part of so many things. It was part of projectile motion. It's part of Newton's second law. Okay, we use acceleration formulas in lots of other things, so expect it to be kind of one of those fundamentals that's going to be part of a lot of things on the final exam. Okay, make sure you know which formulas you have, okay, and how you can use them, what you need for them, okay, things like that. There could be a simple acceleration calculation in the multiple choice. Okay, if I was going to have like an acceleration problem, that's probably where I would put it, and it would be very simple. Okay, not requiring like manipulation or anything like that. Okay. And then from there, we went on to vector addition. How many units did we use vector addition in? 2, kinematics and dynamics, right? Okay, so what we have to remember here is that, okay, we draw our vectors tail to head. Okay, we find, okay, x and y components. Okay, and then we add x and y components. Okay, we arrive at our final triangle, and then it's trigonometry from there. Okay. All right, so that could look something like this. It's just a rough drawing, obviously. All right, so here's vector 1. It's 10 meters in length. Okay, this would be x1. This would be y1, and then sorry, I'm gonna draw our angle in there. Okay, yeah, 1. Okay, and this would be theta 2. This would be x2, y2, and we could say that'd be 8 meters. Okay, so we draw our diagram like that. Okay, drew them tail to head. Our resultant, okay, goes from start to finish, like so. We create our resultants triangle. Okay, so this side here is y1 plus y2. Okay. Oh, sorry, this side here is x1 plus x2, right? And then this is our overall displacement for this graph, which is our resultant. Okay, and then that would be our resultant vector. Okay, so then it's Pythagorean theorem and trigonometry to get the vector. Okay, all vector addition is done like that, including when it's forces, and it's the vector sum of all forces, which is the net force. I mean, that's unit 2, but remember that still applies to that. Okay, should you expect a vector addition question? Yes, expect a vector addition question because there's one. Spoiler alert. Okay, definitely. Okay, and then after vector addition, we moved into projectile motion. That's point number 5. Okay, should you expect a projectile motion problem? It's the first problem in the written response. Spoiler alert. Okay. First problem in the written response section is a projectile motion problem. I will ask you to do exactly the same thing I asked you to do before. Okay, I will give you a projectile. Okay, you'll have to calculate things like its time in the air, its horizontal distance traveled, and maximum height. Same as we did on basically every quiz. Okay, on the unit exam, all of that kind of stuff. Okay, because that question tests everything but graphing from unit 1. It tests vector components, acceleration, v equals d over t, scalars and vectors. Okay, everything but graphing can be tested with a projectile motion problem. Right? Mm-hmm. Yes. Well, I mean, in the real world, no. On the final exam, yes. Yeah, because that's basically the only. I mean, we did 1 or 2 where it dropped below. Those involved a lot more steps. This is a time. There's a time component here, so I'm not going to do that. All right, so yeah, remember things like, okay, in a projectile motion problem, okay, we have our projected velocity, okay, so that'd be VP, our projected velocity, that would be our angle, okay, the object follows that projectile arc, okay, little things to remember, VI equals negative VF from a vertical perspective, okay, here, at the maximum height, VF equals 0. Okay, and this would be our max height. Okay, the vertical component of all this is accelerated motion, whereas the horizontal component, it travels at a constant velocity, v equals d over t. Okay, so what we end up doing is finding our v horizontal, our initial vertical, okay, and we work from there. We find the time in the air, we find all the other stuff, okay, from there. Okay, so definitely make that something you look over. Right. Those are the main concepts from Unit 1. Okay, obviously there were lots of other kind of minor things that we talked about in there, but those were the main concepts from Unit 1. Okay, so those are the things that will appear for the most marks on the final exam. Okay, projectile motion, okay, vector addition, and then the other stuff is fundamental, so it'll be in lots of things. There's a projectile motion problem that's as specific as I'll get. Yeah, I'm giving you quite a bit of information already, so I'm going to keep some things close to the chest. Okay. Other things to kind of think about in terms of kinematics. Okay. Remember your vectors. Okay, your sine, cos, tan, all that kind of stuff. Okay. When I come around and clear your calculator, I usually put it back in degree mode. I usually try to remember to do that, but you should double check. Makes kind of a big difference when you're doing any trig calculations. After it resets, it goes back to radian. Okay, so make sure you put it back in degree mode, okay, because it's kind of a big deal. Okay. All right, other stuff for kinematics here. Okay. We went over a bunch of different acceleration formulas. Okay. And a bunch of stuff to do with the graphs. We looked at how some of those formulas come from the graph. Okay, like a velocity versus time graph. Okay, the slope of the line here. Okay, y minus b over x was vi or vf minus vi over t. That's why the slope of the line was the acceleration. Similar logic for the position versus time graph. Okay, we also said that the area under the line represents what? It represents displacement, and it represents displacement for this reason. Vi times t plus 1/2 at squared calculates d. This is Vi times t because the height of this box is Vi. The length of the box is time. Okay, this triangle here, we could go 1/2 base times height, but that's essentially what 1/2 at squared is doing. Okay, that calculates that. The other one is Vft minus 1/2 at squared. That calculates this big rectangle. That's Vf times t. And then we subtract this triangle, which is the same as this one. It's 1/2 at squared. Okay, that's what gives us the area under the line. Okay, that's calculating displacement. Yes, but no, not the top triangle. It's the whole box, right? Vf is this number here, right? Times t. That calculates that whole rectangle. Then I subtract 1/2 at squared because these two triangles are the same, right? Right, so I subtract that, that still leaves me with this area under the line. So that's where both of those formulas are coming from, right? Remember that the other one we dealt with, the other acceleration formula, or sorry, there were two others, okay, but the really important one was this one, Vf squared equals Vi squared plus 2AD. We used that one a lot with projectile motion and the maximum height. Okay, and then the last one was this one, D equals Vf plus Vi over 2, okay, times T, right? We didn't use that one very much, but okay, it's another acceleration formula that we have. Okay, if we're looking at the position versus time graphs, okay, so this is meters and this is seconds. Okay, if we got a graph like that, right, the slope, okay, is final position, y, minus initial position, b, divided by time, x. Okay, that gives us the velocity of the object. Right? And then we can calculate total displacement, okay, our average, our total distance traveled, average speed, all of that kind of stuff, okay, using v equals d over t if we need to. If this graph isn't linear, then we use those other formulas. Okay, if it's linear like this, we use y equals mx plus b. That's something to note on your final exam. Okay, read the question carefully. If the question, especially if it has to do with graphing, says using your graph and its equation, do the following things, use the equation and the graph to do it. Don't go looking for formulas from your formula sheet. Okay, use the stuff that's on the graph. That basically means it's a linear graph and you have to use y equals mx plus b. Okay, but you need to make note of those things. If it tells you to do it one way, do it that way. Okay, everybody with me on that? It's kind of important. It means I'm trying to test one specific thing. No. If I've got a graph on there, I either build it so you can only do it one way, or I tell you do it this way. Yeah. Okay. Other things. So, okay, your vector addition problem, that could be one of those problems that's a combination problem. Okay, like it'd be really easy to make that a Newton's second law problem. This force plus this force, calculate the acceleration of the object. Okay, that's me combining two units into one question and making the test a little bit shorter by testing two things at once. Okay, so just kind of be aware that's one of those areas that there could be overlap. Okay, it's an easy place to do that. Yeah, I think the question that's out of the most would be like a graphing question that might have an ABC kind of thing, right? But most of the questions are going to be between 4 and 6 marks. That was unit 2. Yeah, that was a sum of all forces, but it was a static question, right? The net force was 0, right? Right. So questions about kinematics? A Cliff question? Yep. Nope. Okay. So we want to solve using just the information we're given here, how far this projectile is going to travel horizontally, as well as its maximum height. So with any projectile motion problem, okay, the first thing we wanted to do was break it up into the vertical component and horizontal component because they experience different kinds of motion. One's accelerated, one's constant velocities. We have to treat them differently. Okay. Right off the bat, I can calculate a couple of things. This side of the triangle will be my horizontal velocity. This side of this triangle will be my initial vertical velocity. Okay, so to calculate my horizontal velocity, it's the adjacent side, so it'll be the cos of 30 times 25. All right, so we got 21.651. Meters per second. Okay, and then I've got to do a similar thing over here. Initial velocity will be the sine of 30 times 25, which will be 12.5 meters per second. Okay, other vertical information that I know. Acceleration is negative 9.81 meters per second squared. And since this is a question where the initial height and the final height are equal, VF is, nope, negative 12.5 meters per second. VF will be 0 at the maximum height where they're not equal. Okay. All right. I want to calculate the horizontal distance traveled, and I know that horizontally the object is traveling at a constant velocity. What do I need? Well, I want to find the distance. To get that, I need, did we solve for time on pretty much every single one we did? Okay. Can I get the time with this information? Yes. All right, so that's going to be T equals VF minus VI over A. Okay, so negative 12.5 minus 12.5 divided by negative 9.81. Okay, will give me my time. Divided by 9.81. Okay, so 2.55 seconds. Obviously, you would not round off. I'm rounding off because I'm being lazy. Is that what you're going to ask? It's gravity, yeah. Okay, then I come over here. I can use that time in this equation to get D. D equals V times T, right? So that'll be our 21.651 times 2.55 seconds. Obviously, don't round like that on the exam. I'm just being lazy. Okay, 55.2 meters. I think I only have two significant figures anyway, so it's 55 meters horizontally. All right, so I had to use v equals d over t. I had to use an acceleration question. I had to find x and y vector components. Now I need to find the maximum height. Okay, the only thing I need to remember that's different is that at the maximum height, my vertical final velocity is 0. Okay, so that'll mean if I want to find the height that I'm looking for a distance, okay, that'll mean Vf squared equals Vi squared, because I know that, okay, plus 2AD. I'm looking for D, so I'm manipulating, it's going to be Vf squared minus Vi squared over 2A equals D. Okay, so 0 minus 12.5 squared divided by negative 19.62. Okay, that's 2 times 9.81. All right, so a maximum height of 8.0 meters. Okay, so again, I had to do another acceleration calculation. Okay, we did tons of questions like that in class. So my warning to you on the exam would be don't let the context of the question throw you. I picked a weird context. No, I mean, it's just, it just has a weird setting. It's not that it's mathematically any different, it just has a weird setting. Okay? No, you can't. That's not a weird situation. Okay, what else, guys? Yeah, but that's dynamics. That's a static question.
For this type of question we just did, are the givens that we got going to be similar?
Yeah.
Like where you get the
Basically, all I have to give you is the projected and the angle, and that's it. You can calculate the rest from there. Yeah. Okay, I did post earlier today the final exam review questions in Google Classroom. Okay, pretty sure I put them in both classes, unlike the lab. Okay. Yeah. All right, the podcasts for review start today. Okay, so this recording will be on there. And you'll be able to kind of watch that as we go, or if you want to review it later or whatever. Okay, but there's some old exam questions in that review package. Okay, there's not much there because I'm going to do this active review in class, so I'm not going to, make up a document that says the same thing that I say in class. So, so you'll have that you can use to get ready. Right. Plus you have all of your assignments, all of your worksheets, your quizzes. Okay, good idea to look over your quizzes. Okay, I mean, whether you kept them or not, okay, it doesn't really matter. If you go into Power School and you click on one of the quizzes in your Power School, it'll open it up and there'll be 2 links in the task. One link will say like quiz 5 questions. If you click on that, it's the document that I posted for you the night before the quiz that has the questions on it. And then the other link will be podcast of quiz 5. You click on that, it takes you to YouTube where I marked the quiz with you, okay, and recorded it so you can see whether you did them right or not. Okay, so that's a good way to, have a question that you can try and then check and see if you did it right. You also have the worksheets that obviously have the answers on them, but not the solution. Okay, if you're not sure how to arrive at that answer, then doing the quizzes and watching the videos of the quizzes is probably a little bit better. Okay, but it's definitely a good idea to look through your quiz scores. Any quiz you didn't do well on, I would suggest having a look at and maybe doing again. Okay, any other questions for kinematics? Maybe there'll be a few more tomorrow. Okay, because tomorrow we'll do some more kinematics. I'll answer some questions on kinematics and then we'll maybe start dynamics review, okay, tomorrow. And then we'll have a little bit more time Monday and Tuesday, okay, for that kind of stuff. All right. Okay, then you can either be working on review for Thursday or working on review for June 24th. Okay, either one, you've got review stuff there. If more questions come up, just ask and I'm happy to answer.